Hey guys, welcome to my channel. Today I am going to explain you all a very interesting topic that belongs to inorganic chemistry, and the topic name is alkali metals which belong to first A group. So before starting our lecture, subscribe to my channel, share and like the video and hit the bell icon for the further notifications. And you all know that the competitive exams are very near, so share with your friends as soon as possible such that they get benefit from this lecture. So without wasting any time, we'll go in through and we will study in a depth about this topic. So it is alkali metals. You all know some of the basic things about this topic, so no worries, we will also study about that basic things and also go into the depth of this topic. So the general electronic configuration of these alkali metals is NS1, and in these alkali metals the lithium magnesium forms the diagonal relationship with each other. We all already know that the alkali metals are nothing but the first A group elements which belongs to the S block, and lithium, sodium, potassium, rubidium, cesium and francium are the elements of these group. And we also know that the first element of any group behaves differently from other metals, like it has the anomalous behavior. So here the lithium also have the anomalous behavior due to the small size, high electronegativity as well as different polarizing power. And we all know that the atomic size increases down the group. So here in the alkali metals also the atomic size increases down the group. That means the cesium has the highest atomic size than lithium, and the ionic radii also increases down the group. That means the cesium has the large ionic radii while compared to the lithium. And the first ionization enthalpy decreases down the group. We all know that the ionization enthalpy is nothing but the removal of electrons from the outer shell. So guys, when we go down the group, the size increases. We already read here that when we go down the group, the atomic size increases. As the atomic size increases, there will be no shielding power, so that we can easily remove the electron from the outer shell, such that the ionization enthalpy always decrease down the group. It means that cesium has big size, so it doesn't need much energy to remove the electron from the outer shell. And the second ionization enthalpy is very high. The second ionization enthalpy is very high because if you remove one electron from the outer shell, it become a stable configuration. That is the reason uh, the second ionization enthalpy is very high. These are all are the physical properties, strengths in the physical properties. And the next one is density. Density always increases down the group. So the lithium is less than, potassium is less than, sodium is less than, rubidium is less than cesium. Here you can see the irregular trend, that is the sodium is having greater density than potassium. This is because of the large size of potassium due to the presence of vacant 3D orbitals. So because of this reason, the sodium is having the high density while compared to the potassium. And the melting point is like decreases down the group. Cesium has low melting point while the lithium is having high melting point. So here we can see the irregular trends in the density, but here there is no irregularity, and the melting point decreases down the group. This is because of the decrease in the metallic bond. Due to the decrease in the metallic bond, the melting point also decreases. Here the next one is boiling point. In the boiling point also, the as we go down the group, the boiling point decreases. The lithium is greater than, sodium is greater than, potassium is greater than, cesium is greater than rubidium. Here guys, you can see the irregular trends. Here the cesium is having greater boiling point than the rubidium. And the electronegativity, in the electronegativity also we can see that it decreases down the group. It means the cesium is having low electronegativity, so the lithium is greater than, sodium is greater than, potassium and rubidium is having the equal electronegativity, then it is greater than cesium. Here the electronegativity decreases down the group. And the next one is SRP. SRP is nothing but the standard reduction potential. The standard reduction potential actually decreases down the group, but here also you can see the irregular trends because the cesium is greater than lithium. It means the lithium is having lesser standard reduction potential, and the trend is like sodium is greater than, potassium is greater than, rubidium is greater than, cesium is greater than lithium. Here guys, you can observe that there is a irregular trend in the density, in the boiling point, as well as standard reduction potential. So we need to remember all these things obviously. And in the alkali metals there is a large abundance of sodium. It is in the 7th position. The abundance of sodium is very high, and the oxidation state of the alkali metals is always +1. So the oxidation state of the alkali metals, that is first A group elements, is always +1. And now I am going to explain some of the important points which is also very much important for your competitive and for this topic, that is the superoxides are orange colored. You must remember this. The superoxides are orange colored and its bond order is 1.5. It is paramagnetic in nature. The superoxides are orange colored, its bond order is 1.5 and it is paramagnetic in nature. And the peroxides are basic in nature. The peroxides are basic in nature. The chromates are yellow colored. The chromates are yellow colored and permanganates are pink colored. You might have an experiment in your 8th or 7th class, that is potassium permanganate, which gives the pink color. So you can remember like permanganates are pink colored. And the next important topic, that is flame colors. The alkali metals have gives the different flame colors, that is lithium is having crimson red color, sodium gives yellow color, and the potassium gives blue color, rubidium gives red violet color, cesium gives blue violet color. Once again let us see. The lithium gives crimson red color, sodium, that is yellow color, potassium blue color, rubidium red violet, cesium gives blue violet. And guys, the next physical property is the reducing nature. Here the less reduction potential values are good reducing agents. Here we can also conclude one point, that the reducing nature is inversely proportional to standard reduction potential. As whenever a metal having less reduction potential value, it is having good reducing agent. So here we can conclude that lithium is greater than cesium, is greater than rubidium, is greater than potassium, is greater than sodium. But in the reduction potential, we found the trend like sodium is greater than potassium, is greater than rubidium, is greater than cesium, is greater than lithium. But here the reducing nature is inversely proportional to the standard reduction potential values. So the trend will be like lithium is greater than cesium, is greater than rubidium, is greater than potassium, is greater than sodium. And the next important property is hydration enthalpy. It's a physical property. In the hydration enthalpy, lithium plus is greater than, sodium plus is greater than, potassium plus is greater than, rubidium plus is greater than cesium. So the hydration enthalpy also decreases down the group. The lithium has the maximum hydration enthalpy. And the next point is when the alkali metals in the liquid ammonia gives deep blue colored solution. When the alkali metals are in liquid ammonia, they always gives deep blue color. This solution acts as a good reducing agent. The solution of alkali metals in liquid ammonia acts as a good reducing agent, and it is a paramagnetic nature and it is having paramagnetic nature. And when this blue color, deep blue colored solution changes into bronze, it becomes paramagnetic to diamagnetic. See, when it was in liquid ammonia, it gives deep blue colored solution and that solution was paramagnetic. When the blue color changes to bronze color, it becomes diamagnetic property, diamagnetic nature. And the reactivity of alkali metals is very high. Like when we expose them to the atmosphere, they become tarnished, so they must be stored in the inert gases like kerosene, such that they should not expose to the atmosphere and cannot get the tarnish on their surface. And the heavy alkali metals form superoxides. Here the heavy alkali metals always tends to form the superoxides, and the heavy alkali metal is cesium. So cesium is a strong superoxide. Sodium forms peroxides. Lithium forms the normal oxides. The peroxides have basic nature. The peroxides always obtain the basic nature. They absorb the carbon dioxide from the environment and releases oxygen. The peroxides like sodium have the basic nature, absorbs carbon dioxide and releases the oxygen. Next one, these peroxides are used for purifying the air. The peroxides are used for the purifying the air and also used in qualitative analysis of salts. These peroxides are used in qualitative analysis of salts. The normal oxides are also basic. The normal oxides like lithium are also basic, and the solubility of both oxides and hydroxides increases down the group. This means that the solubility of cesium oxide or cesium hydroxide is greater than the lithium oxide or lithium hydroxide. And the main important point is that the alcoholic potash is used in the organic chemistry for dehydrohalogenation. The alcoholic potash is used in the organic chemistry for dehydrohalogenation. These are some of the important points in the alkali metals. Now let us discuss about carbonates, bicarbonates and nitrates. So the carbonates, the general formula of carbonates is M2CO3. The carbonates having the general formula, that is M2CO3, and the thermal stability and the solubility increases down the group. It means that the cesium carbonate having the high thermal stability as well as solubility while compared to the lithium carbonate. And the next one is bicarbonates. The general formula of the bicarbonates is MHCO3, and they are basic in nature. But in the bicarbonates, the lithium bicarbonate does not exist while the other alkali metal carbonates exist. These carbonates and bicarbonates liberates carbon dioxides. We studied that the peroxides absorb the carbon dioxide and releases oxygen. Here the carbonates and bicarbonates liberates carbon dioxide gas. The next one is nitrates. Nitrates having the general formula is MnO3. On heating the nitrates, they forms nitrites. And the alkali metals forming complex formation, alloy formation. In the complex formation, the lithium forms some of the complexes because of the small size, while the other alkali metals having the bigger size, so they cannot form the complex, but the lithium can form some of the complexes. In the alloy formation, they form amalgam with mercury, and the combination of lithium plus lead gives white metals. These are some of the alloys. And the next one is the uses of alkali metals. So this is the main important point, that is the lithium is used to make alloys. Here we have already studied that the lithium is used for making of alloys. Lithium plus lead, that gives white metal. Lithium with aluminium useful for production of aircraft parts. Lithium plus magnesium are useful for armor plates. Sorry, it's an armor plates. Lithium plus magnesium, and also they are used for making electrochemical cells. So these are some of the importance of the alkali metals. Lithium plus lead is used for white metal. Lithium plus aluminium is used for aircraft parts. Lithium plus magnesium is used for armor plates and also used for electrochemical cells. The liquid sodium is used as coolant. KCl, that is potassium chloride, is used as fertilizer. KOH, potassium hydroxide, is used for manufacturing of soft soaps. And the cesium is used in devising petrochemical cells. The liquid sodium is used as coolant. KCl is used as fertilizer. Potassium hydroxide is used in the manufacturing of soft soaps. Cesium is used in devising the petrochemicals. These are the uses of the alkali metals. And the next most important topic is, that is the compounds of sodium. Sodium forms different types of compounds. Some of them are sodium hydroxide, sodium carbonate, sodium bicarbonate, sodium sulfide, sodium chloride. These are the compounds of sodium. So now we are going to learn them one by one with the properties, preparations as well as uses. The first one is sodium hydroxide. The sodium hydroxide is soapy to touch, and it decomposes the muscle proteins and make a pulp. The decomposition of the muscle protein and making into pulp, this property is called as caustic property. So usually the sodium hydroxide is called as caustic soda because of this caustic property. Preparation of NaOH having two methods. First one is electrolytic process and the another one is the Kastner-Kellner process. The electrolytic process is nothing but electrolysis of brine is used for the preparation of NaOH. So the electrolysis of brine which is used for the preparation of NaOH, and the NaOH is prepared purely by this process. The byproduct of this preparation is H2 as well as Cl2. The reaction is 2NaCl plus 2H2O gives rise to 2NaOH plus H2 plus Cl2. Here are the byproducts formed, H2 and Cl2, and the pure NaOH is formed by this electrolytic process. And the next important process for the preparation of NaOH is Kastner-Kellner cell. In this Kastner-Kellner cell, there is a rectangular iron tank which is divided into three compartments. At the bottom, it is fitted with the electric wheel such that the mercury can be brought into the circulation in all chambers. And the brine solution is filled in the outer chamber. The dilute NaOH is in the middle chamber. So there are three compartments. The brine solution in the outer chamber, the dilute NaOH in the middle chamber, and the graphite electrodes into the brine solution acts as an anode. The graphite electrodes are kept in the brine solution which acts as anode. The iron in the NaOH solution. The iron is kept in the dilute NaOH solution which acts as cathode. And the mercury acts as an intermediate electrode. The mercury acts as an intermediate electrode. In the outer compartment it acts as a cathode. In the middle compartment it acts as an anode. The mercury in the outer compartment acts as cathode, and when it is kept in the middle compartment it acts as anode. So it acts as an intermediate electrode, that means either cathode or anode. The chlorine is oxidized at graphite rods and sodium amalgam is formed at mercury layers. So the chlorine is oxidized at graphite rods and the sodium amalgam is formed at the mercury layers. The reaction is 2NaCl gives rise to 2Na plus Cl minus, which is formed at the cathode which is formed at the anode. The 2NaCl gives rise to 2Na plus Cl minus, which is formed at the anode. At cathode, Hg plus 2Na plus 2 electron minus gives rise to Na2Hg. This is sodium amalgam. The amalgam found in the middle compartment get oxidized to form the sodium cations. The amalgam which is found in the middle compartment, this is oxidized to form the sodium cations, that is Na2Hg gives rise to Hg plus 2Na plus 2 electrons minus, and at the cathodes 2H2O plus 2 electron minus gives rise to H2 plus 2OH minus. After the oxidization at cathode and anode, the solution is concentrated to form NaOH, that is 2Na plus 2OH minus gives rise to 2NaOH. This process, Kastner-Kellner process, is a continuous process of preparation of NaOH. It is a continuous process of preparing NaOH, and the physical properties of the physical properties are it observes the atmosphere. It does not observe the atmosphere but also dissolve to form the solution. This property is called the deliquescence. The NaOH has a different kind of property, that is, it does not observe the atmosphere but it dissolves in it to form a solution. This property is called as deliquescence. And the NaOH, as we already read, it is soapy to touch and it is very bitter to taste. And when the NaOH falls on our skin, it causes wounds due to its caustic property. We have already read that the NaOH have the caustic property. So due to that property, when it falls on our skin, it causes wounds and it absorbs the carbon dioxide from the atmosphere. It melts at 519 kelvins. The NaOH absorbs the carbon dioxide from the atmosphere and it melts at 519 Kelvin. These are some of the important properties which you have to know it. And the next one is the chemical properties. When the NaOH reacts with the acid, this is the total reaction. It forms the salt. The reaction is NaOH when reacts with the HCl, hydrochloric acid, it forms NaCl plus H2O. The NaCl formed is a salt. So the conclusion is that when NaOH when reacts with the acid, it forms the NaOH reacts with the metal, that is zinc. 2NaOH plus Zn gives rise to 2Na plus H2 plus ZnO2. It means that when NaOH reacts with the metal, it liberates the hydrogen gas. And when the NaOH reacts with the non-metals like F2, then it will be the formation of oxygen difluoride. That is, the reaction is F2 plus NaOH gives rise to NaH plus OF2, the production of oxygen difluoride. And when NaOH reacts with the phosphorus, it gives phosphine, that is P4. And when the NaOH reacts with the silicon, it gives sodium silicate, that is Na2Si plus H2O. And the next most important is the uses of NaOH. NaOH is an important reagent in the laboratory. It is very useful. It is used in the cleaning of glassware in the laboratory, and it is used in the production of pure fats and oils. It is used in the manufacturing of soaps, rayons, paper and pulp, and also it is used in the petroleum refinery and mercerizing of cotton, purification of bauxite. So these are the main important uses of the NaOH. That is, it is used to clean the glassware in the laboratory, production of pure fats and oils, manufacturing of soaps, rayons, paper, pulp, used in the petroleum refinery, as well as mercerizing of cotton, purification of bauxite. And the next most important compound of sodium is sodium carbonate. The formula of the sodium carbonate is Na2CO3, which is called as soda ash. The formula, that means the sodium carbonate is called as soda ash, and the decahydrate is called as washing soda or salt soda. So here the Na2CO3 is called as soda ash, and Na2CO3 into 10H2O is called as washing soda. It is a decahydrate. The preparation of sodium carbonate is prepared by the Solvay process, and the raw materials used in the preparation of sodium carbonate is NaCl, limestone and ammonia. The raw materials used is NaCl, limestone and ammonia. The properties of sodium carbonate is that the sodium carbonate is white crystalline solid. It is a white crystalline solid. It loses water of crystallization to atmosphere. Like when we heat this washing soda, it loses its water and becomes a soda ash. And the soda ash, that is Na2CO3, is thermally stable. The melting point of the sodium carbonate is 852.1 degrees centigrade. The melting point of sodium carbonate is 852.1 degrees centigrade. And uses of the sodium carbonate is, it is used in the softening of water. As it is a washing soda, it is called as washing soda and have the properties of washing soda. It is used in the laundries as washing soda, fire extinguisher, petroleum refinery. It is also used in the qualitative and quantitative analysis, manufacturing of glass, borax, caustic and baking soda. So these are the main important uses of the sodium carbonate, that is softening of water, laundries as washing soda, fire extinguisher, petroleum refinery, qualitative and quantitative analysis, manufacturing of glass, borax, caustic and baking soda. And the next important compound of sodium is sodium bicarbonate. The formula of the sodium bicarbonate is NaHCO3, which is called as baking soda. And the preparation for the sodium bicarbonate is ammonium carbonate on reaction with brine gives the sodium carbonate. Here the ammonium carbonate is used for the preparation of sodium carbonate, as well as brine solution is also used. The reaction is NH4 taken twice CO3 plus 2 NaCl plus H2O plus CO2 gives rise to 2 NaHCO3 plus 2 NH4Cl. And also the sodium bicarbonate is also prepared from the sodium carbonate, that is the reaction is Na2CO3 plus H2O plus CO2 gives rise to 2 NaHCO3. So here the sodium carbonate bicarbonate is prepared from the sodium carbonate. And the properties of sodium bicarbonate is, it is white crystalline solid as sodium carbonate. It is least soluble than NaOH and Na2CO3. It means the solubility of sodium bicarbonate is very low while compared to sodium hydroxide and sodium carbonate. And methyl orange gives yellow color for the indication of sodium bicarbonate. Phenolphthalein gives no color. So these indicators can be used to distinguish Na2CO3 and NaHCO3. So it is used in the distinguish of these two compounds. And the main use of the sodium bicarbonate is, it is a mixture of the uses of the sodium bicarbonate is, if the mixture of sodium bicarbonate and the tartaric, the mixture of these two, sodium bicarbonate and tartarate, is used as the baking powder. The mixture of sodium bicarbonate and tartarate is used as a baking powder, and the sodium bicarbonate is used as an antacids in the cool drinks, and it is also used in the fire extinguishers. The fire extinguishers consist of the mixture of sodium bicarbonate and sand. So here the dry fire extinguishers consist of the mixture of the sodium bicarbonate as well as sand, and it is also used in the mild antiseptic for skin infections. And the next most important compound of sodium is sodium chloride. Naturally, the sodium chloride is available in the sea water as well as land lakes. So the content of NaCl in the sea water is about 2.7 to 2.9 percentage by mass. So in the sea water it is contained about 2.7 to 2.9 percentage by mass, and pure NaCl is obtained by saturating NaCl solution with HCl gas. The pure NaCl is obtained by saturating NaCl solution with HCl gas. The properties of these important compound, that is sodium chloride, is it is face centered cubic structure. We will study about this in the solid state of class 12. So it has face centered cubic structure in its crystalline form. This structure is called as rock salt, and it melts at 108 degrees Kelvin. And the uses of this sodium chloride is it is used in food for taste and maintaining pressure on the cell wall. It is also used in the preservatives for pickle, meat and fish, and the raw material, and it is used for preparation of raw materials for manufacturing of NaOH, Na2O2 and Na2CO3. This is the most important compound and the uses and their properties. And the last topic of this alkali metals is biological importance. The metal having the biological importance, and the sodium is present in the blood plasma, and the transmission of nerve signal and regulating the flow of water, sugars and amino acids in the cell. It is also useful in the maintaining the osmotic pressure in the cell wall. These are the biological importance of the sodium. The biological importance of potassium is that it is useful in the activation of many enzymes, participate in the oxidation of glucose to produce the ATP, adenosine triphosphate, and it is also responsible for transmission of nerve signals. It is also used in synthesis of proteins. And the important point is that the process of pumping of sodium ions from the cell and taking potassium and hydrogen ions into the cell is called the sodium potassium pump. The process of pumping of sodium ions, it means that taking the Na plus ions outside and taking the K plus and H plus ions into the cell. This process is called a sodium potassium pump. And 1/3 of ATP is used by resting animal and about 15 kgs per 24 hour in a resting human. The 1/3 of ATP used by resting animal and about 15 kg per 24 hours in a resting human. The presence of Na plus and K plus ions inside and outside the cell produce on electrical potential across the cell membrane. So these are the most important biological importance of these metals. I hope you guys understood the entire topic. This comes to end of the video, and I hope you might feel confident on this topic and have some grip. So share this video with your friends and also subscribe, like and hit the bell icon such that you will never miss the further updates. Thank you and all the best for your competitive exams. I hope you just understood this.